Welcome back, everyone. Coming up to the last session, thank you so much for staying with us here all day in Detroit. And for those of you watching online, either just joining us or continue to join us, welcome again to our last session of the day, and what a day it has been. We'll talk about that in a little more in a little bit. But first, what is all the fuss about a tiny little chip? These things are so small, they're measured in nanometers. I don't even know how small that is. I think they're getting so small that soon they're going to not even exist, which will probably be better for everyone if it could be that, but unfortunately it's not. We thought about trying to get one actually for this event and kind of passing it around, but it would have cost about $700,000 and take 8 months, so we gave up on that one. No, in all seriousness, it is quite a big fuss. It is a big deal. Many in the industry could have potentially seen it coming, but we didn't, and there we are, and so now we have to live with it and learn. It's a critical part, the semiconductor, to say the least. And although we're seeing some mitigation, right, plant shutdowns, decontenting, trying to move to analog features, I don't think anybody thinks the long-term solution here is fewer semiconductors, not with the digitalization of vehicles, connectivity, electrification, all of it coming, etc. We'll hear about some data in a moment, but I think from the latest forecasts that I've seen, something like 10.5 million vehicles of lost production for this year, and going deeper into next year as well. This little chip is quite a big deal, as it turns out. Before we kind of bring on our experts, and we have some really fantastic guests here to talk about the issues and the solutions, we do want to get your opinion on how long you see this crisis taking. We have a poll, it's already open. For those of you in the audience, you can get that via the app. Just click into the session, Rethinking Semiconductor Supply Chains, and you'll see the option for a poll. How long do you think it's going to take? How long do you expect the current shortage to significantly impact on vehicle production? The options are mid to late 2022. Well, let me start it from the optimistic point of view. End of 2021, early 2022, mid to late 2022, 2023, or 2024 or later. So if you haven't yet, sign into the app, give us your vote. For those of you watching at home, please check it out and let us know. Let's find out how optimistic or pessimistic you are. But where do we go from here? Regardless of what the option turns out, where do we go from here? How do we avoid this later on? Is it massive investment in new chip capacity? I think so. More localization of productions of chip production, away from some of the perhaps limited regions, whether it's Taiwan, etc. I think it probably sounds like a good idea. Direct OEM purchasing, more closer relationships in the supply chain. Sounds good. Partnerships, even joint ventures, maybe, between OEMs and chip makers. We heard Tesla even talking about making their own chips. Don't know how viable that is, but it's talking about it. Or what about the other solutions that we've been talking about all day? Visibility in the supply chain, joined up planning, connected systems. Perhaps there's a role to play there as well. Or perhaps it's just all of the above. Wouldn't be too surprised. To talk about this today, we have, appropriately, a hybrid panel with some using semiconductors, no doubt, to actually connect with us, as well as an expert joining us. I'm really happy to welcome Chris Stiles, Vice President of Supply Chain Management at Nissan North America. Really glad to have you here, Chris. Thank you. And joining us from around the world, really, we have two other experts. David Anderson. David is the president of Americas, an important organization that has a lot of great information on the semiconductor supply chain and is doing a lot of work with the automotive industry. Americas. David joining us from, I believe, California. So David, thank you so much for joining us. And Raman Mehta. Raman Mehta is CIO and Senior Vice President of Johnson Electric. He's had a great career in the automotive industry as well, including as CEO of Visteon up until recently. So Raman certainly knows about software-focused, electrical-focused companies, and no doubt some of the roles that semiconductors play there. So really pleased to have all of our guests with us, both here and virtually. Before we go in, let's pull out that poll really quick and just see where you were thinking and how optimistic or pessimistic you were, if we can just see those results. Because then we're going to hear first a short presentation from David, who will give us some key data and points. But before we do, David, just to cue it up, I'm going to show you if you can see it from where the screen is. 51% see the issue getting better mid to late 2022, 31% to 2023, just 13% think it'll get fixed in the next couple of months by the end of the year or early next year, and 5% see it even 2024 or later. So that's the audience point of view. Let's see how that matches up with some of the industry. So I'm gonna hand it over to David first to share some slides before we go into Q&A. Thank you, David.
Thank you. And thank you for having me here. It's a pleasure to be involved in this conference.
We may have a slight audio issue here. Sorry, David, we've lost audio. Can we just test that again?
Can you hear me?
Can hear you now.
Okay, great. Well, thanks again. Thanks for having me here. And it's a pleasure to participate. And to kick us off, I just wanted to put up a couple of slides to kind of frame the discussion and provide some food for thought for the discussion as we move forward this afternoon. Since this is the Automotive Logistics and Supply Chain Conference, I thought it would be appropriate to start with a quick view of the semiconductor supply chain logistics. So if you could show the next slide, please. In a typical process, for making a semiconductor chip, the equipment and the materials come from all corners of the globe. And they go to what we call a front-end facility. It's a fab, colloquially. It's a fabrication facility for making the devices. And I think a lot of learning and discussion has gone on with this shortage over the last several months about the complexities of chip design, which can take 12 to 18 months for a new chip design to be produced, as well as the manufacturing process for manufacturing a chip as small as it is, because we are working at an atomic scale and in nanometers, as was stated earlier. It's about a 4-month process from starting a wafer, which is a disk that contains many chips, to finishing manufacturing that wafer. It's about a 4-month process. And then it goes to assembly and packaging, typically in Southeast Asia, for packaging of those devices and testing. And then after test, they typically go to a manufacturer, electronic product manufacturer, say in China or otherwise, that would put that into an end product, which ultimately then gets shipped to its point of distribution and point of sale. So in the course of that, a typical semiconductor chip goes across many regions, ultimately touches down in 4 or 5 countries, several states across the US. It'll make a few trips back and forth across the world. And by the time it reaches its end destination, it will have logged upwards of 25,000 miles in its frequent flyer account before it even reaches the end consumer. And that logs about almost 2 weeks in transit time, even though that transit is all by air. So if we could take that in consideration into the logistics of it, I'd like to give you a little view of the market. So if you go to the next slide. The semiconductor value chain is the market for semiconductor chips this year should end the year greater than $550 billion. That's going to be about a 24% increase over 2020, which was also a double-digit growth year. So some of the complications of the supply chain is that we were already in a growth year when we saw a reduced demand in the automotive space. Of course, the other markets were continuing to grow during that time period. And so because a lot of the shift has gone to foundry, that capacity shifted to the other markets. When the automotive demand came back, the other markets still continued to grow. and we've run into this allocation situation that we're in today. So in 2020, of course, we saw shortages initially in the automotive, but that has really spread across the board to nearly all products that are being manufactured. If you go to a Best Buy, it's hard to find electronic products because of the chip shortage. And a lot of that is in the legacy technologies. And what I mean by that is the larger dimension products that go into industrial and automotive because of the difficulty of increasing capacity in those manufacturing facilities. The equipment that manufactures the chips last year was about $65 billion. Again, a pretty significant double-digit growth over 2019. But this year, we're going to end the year at about $82 to $85 billion in equipment sales to manufacture chips, which is about a 30% growth rate. So you can see that the growth in that is stretching that supply chain pretty hard as well. But that supports the capital investment being done by the chip manufacturers. And we're seeing an accelerating investment in both 200 millimeter and 300 millimeter fabs. What I mean by that, that's the diameter of the wafer that the chips are made on. Typically, 300 millimeter is the newer technologies, the smaller geometries, if you will, of the device, and what we would call the leading edge manufacturing processes. But in the next 3 years, we're going to see about 22 new 200 millimeter fabs being built across the globe. 5 of those will be in the US. And in 300 millimeter, which is the leading edge technologies, we're going to see about 50 new fabs built across the globe, 5 in the US, the bulk of them in Asia, of course, Taiwan, China, and Korea. But that's a remarkable 45% capacity growth expected over the next 3 years. So to answer the question earlier of the timing, certainly it will be, in the front end of that 3-year period. I doubt that it will take clear to 2024, but as those fabs come online, we'll see an easing of the capacity. But to be fair, to build a 300 millimeter fab today is tens of billions of dollars, on the order of $30 billion for a leading edge fab, and about a 2-year construction and process for qualifying the processes on the fab before it begins production. So it is a fair length of time, but fortunately some of those fabs have already broken ground and are already in construction in Taiwan and other places. If you go to the next slide, you can see kind of where we are today, which is a very interesting thing. We feel that we're in the beginning of a multi-year growth cycle in chip manufacturing, and some of that is being pushed by the geopolitics of semiconductors. Clearly, the shortage in automotive and other industries has brought a spotlight focus on the importance of the semiconductor supply chain in national interests. So around the world, there's been funding allocated to support the semiconductor industry. In the U.S. alone, the Senate has passed the United States Innovation and Competition Act that provides for $50 billion in funding for U.S.-based semiconductor manufacturing. There's other proposals on the table for support of research and development in that space. South Korea has an unprecedented $450 billion allocated over the next several years for building fabs in Korea, mostly in support of the memory market. And of course, China continues to subsidize investment of the industry in their region to build out the capacity in support of their economy. And even Europe and Japan have announced pretty aggressive and ambitious desires to have a significant portion of the worldwide production produced in those areas. So if you take a look at the right-hand side of the chart, you can see that nearly every region across the globe will be expanding capacity over the next 3 years, largely led by the expansion of foundry activity in Taiwan and, of course, memory in Korea. And then the next slide. But really, all of that growth does not come without some risk. And, I think we've seen with the Delta variant and the slower vaccine rollout in various areas of the world that a new variant could raise concerns over extended restrictions on travel and other activities around the world that could slow the pace. With the expanded capacity coming online, materials and components for building the equipment are in short supply. And that really could cap the momentum for several sectors. And the stretching and the increased lead times on tool delivery is a concern to the companies that are putting that new capacity in place. Foundry capacity, which is the fastest growing area of semiconductor manufacturing, has tightness today, and that tightness in 200 millimeter, which is the legacy type devices, which largely in history has supported automotive, will continue well into 2022. Although we're seeing a lot of that automotive chip design shifting to smaller geometries, which then can move into the 300 millimeter capabilities, and that will ease the pressure on that supply as well. But with all these shortages, we're facing some inflationary pressure on both the demand and the supply side. And of course, we're seeing some double booking or overbooking or booking from multiple suppliers for the same build. And that could lead to an inventory correction when all these lead times normalize. But I do think the players are shaking the supply chain to see where that inventory lies to try to make sure that that correction is minimized if it does occur. But I think also importantly in front of us, the geopolitical tensions that we see, not only from the side of the investment that I mentioned earlier, but the trade and other tensions across the globe, particularly what we've seen in the last few days across the Straits of Taiwan, could lead to supply chain disruption and slow down capacity growth or even the M&A pace across the world. So these are some of the headwinds we're facing, but it is a very positive outlook for the semiconductor market and the capacity coming on board, which will support the growth in markets such as automotive and other electronic end users. With that, I'll turn it back over and thank you. Looking forward to the discussion.
Thank you, David. I think that really sets the scene, gives us a very good sense of what's happening, but also the, as you point out, massive growth happening in that industry, but not without its own supply chain capacity concerns and risks as well. I want to start with you, Chris. Nissan, your organization, is responsible for a lot of the order process and capacity forecasting in Nissan supply chain. So I guess firstly, just to start at the simple level, is your expectation aligned with what we've just heard in terms of when this starts to ease and how you're planning around that, or is there any different thing you would point to?
No, it's very much aligned with what David basically described. So, from our side, it's a lot of what's the immediate kind of reaction and how do we adjust and adjust production schedules and work on what is our demand forecasted versus what can we get. And then the midterm is over the next 2 to 3 years, and then long term from there. But everything we're seeing is pretty much the same as what David explained. So.
Which of course means still prolonged disruption, but nothing is a guarantee about when it comes, given what David has just outlined. Raman, I wanted to also, from your perspective, partly as well because you've worked perhaps a bit more closely with the electronics industry than others in the automotive space. So just, first of all, how you see the crisis, this current crisis, and expectations for it, how it will develop.
Thank you, Chris. Great to be here. One thing I would say, supply chains are becoming supply networks. And what has happened now with this triple whammy of COVID, the shipping container shortages, and the semiconductor, the whole information technology discussion is coming to be at a point where the CEOs and boards are heavily involved. And all the traditional norms of longer planning times and a lot of cushion, safety stocks, they've completely kind of turned upside down. And the things that are exposing now that the enterprises have not spent enough in their information technology infrastructure. And the reaction times are becoming very, very compressed. So when I talk to my CEO and my colleagues, we are really looking at both inward and outward. And really the digital threads that we talk about, the connectivity of our systems is becoming very, very important. And how do we take our planners who are anyway a lot of under stress in the regular times and give them the tools so that they don't have to discover the information into a variety of spreadsheets and really come to a connected system and figure out where they can take the action today. Where can we work more closely with our OEM customers? How can we provide the right demand signals to our suppliers? So all of those things have become very, very important. And to your point, at Visteon and now at Johnson Electric, if you see the vehicles are becoming, when you go to buy, the first thing you are not looking under the hood, you're looking inside the dashboard, you're looking the experience, and it's all built around electronics. As a consumer, we want the same experience in our automotive, the connectedness. The cars are like wine. They are getting better all the time with the over-the-air upgrades. So this thing is going to continue. And the challenge for us is really work on the fault lines that have been exposed and use this opportunity to strengthen our information systems, our networks, and the collaborations.
Thank you, Raman. Let's talk, that was some great points, I think, from Raman on how some aspects of responding. But Chris, I wanted to bring you back in here as well on some of the mitigation, the short term. Let's talk about more in that. Now, we all know there's production shutdowns, and I mentioned up front, some cases decontenting, prioritization, clearly of perhaps higher margin vehicles as such. I'm sure you're doing all that and continue to need to do all that. Are there other things you're looking at, whether with suppliers, logistics providers, the chip makers themselves, in that short critical phase to try to alleviate some things?
Yeah, one thing I'll say, and my team's probably tired of hearing it, my goal always is, from a supply chain standpoint, to be invisible to the company, right? If everything's going the way it should, then we should be invisible. The plants are running, cars are getting delivered, customers are happy. And right now, we are the opposite of invisible. I speak with, the point came up from Raman about, CEO level type discussions. I speak with our chairman almost every day because he wants to know what's the latest. So, the short term, obviously, yes, we have implemented a lot of whether it's daily meetings, we have a control tower that globally looks at the situation. We have control towers regionally. We look at the situations. We do joint discussions daily with the tier one suppliers. We do it jointly with the tier ones and some of the chip manufacturers together, just to at least understand what is the reality of the situation. This is the very short term. I mean, this is when you're talking, what are we going to produce next month? So we've really implemented all of those triggers almost as a type of war room mentality of, okay, we got to get through this day by day, week by week, month by month, for now, until things start getting better from a visibility standpoint on what to expect. So, yeah.
I mean, we heard it earlier today. I think Kelly Bysouth from IAC said, in many ways, it's even more difficult than during the COVID period, let's say, the shutdown restarts, or at least as challenging. And we know then we went to war room mentality too, to pull these together. So clearly that's becoming almost part of this new normal, it seems. David, from your point of view, because you at Semi Americas kind of have contact across that supply chain in different points, and so as well as the kind of mitigation things I've been mentioning, what else are you seeing in terms of short-term responses to try to avoid some of the worst that we're seeing now?
Well, because we've had a couple of years of double-digit growth, we've actually been implementing incremental capacity where available across the board, and kind of run out of physical space to do that. And so we're working across the supply chain to make sure that we can mitigate or at least understand any potential areas for shortage, whether it be raw materials, components going into the equipment, and working with all end markets, frankly. But in this case, in particular with the automotive end market, we formed what we call Global Automotive Advisory Councils in 5 regions across the globe. We have one in North America, Europe, Taiwan, Japan, and China, where we're working with and discussing with the suppliers, at all elements, all levels of the chain, including the automotive manufacturers, tier ones, component suppliers, equipment suppliers, device makers. And, we've been meeting on a regular basis. Of course, we can probably affect more the longer term solutions rather than the day-to-day war room that Chris described, because as an association bringing people together. We don't make those, we can't get involved in those decisions, but we can certainly bring the chain together to understand where the weak points are and for the future supply where they go. Ironically, we found that one of the things that's extending tool lead time for semiconductor manufacturing equipment is the inability to get chips, to make the equipment to make the chips. So, we've had some discussion around that across the industry as well. So, the automakers aren't alone. Our industry is suffering from the same issue inadvertently as well. But, bringing those, as the list that you rattled off at the very beginning, I think it's all of the above, increasing the visibility, co-investment, detuning, and, the capacity increase, the investments being made there, all will help ease it. I think the surveys actually, I would say if you surveyed the semiconductor companies, they'd probably have almost the same profile. That, probably at least half or just slightly over half think we'll be out of this, late next year. But, there are some potential areas of extension.
One of the things I want to learn a little bit more from the panel about is how the relationships between OEMs and the chip suppliers or manufacturers in automotive space and the chip makers may be sort of changing and evolving. It's sort of my understanding that in general there's been something of a divide historically. The chips were perhaps sourced through a tier one and other, and perhaps now that starts to change. But I want to maybe start with you on that one, Ram, and again, not least with a background in a highly electronic infotainment space as well. Perhaps there was different relationships, but how do you see those relationships evolving now?
Definitely, Chris. I think now from a tier one, you start hearing the word tier 0.5. So what's happening is now the chip manufacturers, the SoC, the systems on chip, they are actually going directly to the OEMs with their toolkit, with their software, their algorithms, and it's kind of disrupting in a big way. And you're totally right. A lot of OEMs are looking into designing their own chips because if you'll see now, the machine learning, the computer vision, the AI is becoming very big differentiator. In fact, if you hear some of the big OEM CEOs, they are talking about the revenue from their software and the content will probably start to ramp up very quickly as they make from the original equipment sale. So the stakes are very high. The business models are changing. But the way I see it is more about collaboration. And all of the whole supply chain, including the tier ones, tier two, the OEMs, we are all becoming very software centric. And the second trend that I see with this whole thing coming in together is the role of AI. The more the data we have today, we can make more precise decisions. And that's going to be the key as to how we share this data, how can we drive the right predictions that can make all of the supply chain efficient, not for just one company, for the whole network. So I think this is kind of for giving us a big opportunity to become more digital, all the way we design the products, the way we collaborate in supply chains and the aftermarket. So a lot of exciting things happening right now.
Chris, from Nissan's point of view, whether it's your supply chain organization or perhaps other parts of the organization, do you note some shifts and change in that relationship?
Yeah, I mean it's occurring basically by necessity. So definitely it's evolving, and like I was saying, in the immediate, the short term, everybody's kind of looking for what is that next way to get a better jump on the information. What's a better way to get visibility, predictability for where we're at? But then in the midterm, I think, from a predictability, forecasting standpoint and all that, the AI tools, the technology that's there, everyone I think is now realizing we got to move a bit faster and start really implementing some of those tools to help us deal with what we're dealing with every day right now. So, yeah.
And David,
just to add to Chris's point, this visibility becomes very important. And what we are getting exposed to is our own internal systems, there's a lot of latency because, as a company, we do a lot of internal buying and selling. One part makes one sub-assembly, it goes to the next plant. How can we cut that time down and really start to harvest all that information and what Chris mentioned to provide visibility into long lead items at a company level, kind of explore that bill of material and look at all the electronics that you would need to protect the vital interests of your OE customer. And that's where this information thread comes very, very important.
Yeah, and if I could add on to that, I think the latency issue is a really important one. And we think of that in the chip supply in terms of timing and access to data, processing time and results, especially in AI-driven autonomous systems and that sort of thing. So we have seen, over the past several years, a shift from the OEMs starting to look at designing their own chips to support the autonomous systems and kind of those critical elements that are using AI. But it's then shifted to the other products as well. Because if you think of, in terms of a smart city, do they use the cloud or they use edge computing? Well, the vehicle itself requires much more onboard processing to reduce the latency of the information flow. And so you have onboard gathering of data, storage of data, processing of data, which ultimately drive the semiconductor content well into the future for all automotive vehicles.
It feels very meta as well, talking about latency and connectivity when we're doing this hybrid method as well, so we can see it coming right to life. Chris, it feels like every time we have a major crisis, we learn new places on the supply chain map. Malaysia, as we talked about, it certainly wasn't apparent to me that Malaysia would be the thing that brought down more OEMs when something happened. Is this once again? I mean, clearly it has exposed some weaknesses, but to look at it from a positive, is it helping in the longer term view to better understand those intricacies of the supply chain and where some of those risks may sit?
Well, it's forcing the need to understand better kind of where are the risk points. And to be honest, I mean, the risk points today versus the risk points we had in maybe 2011 when we had the earthquake and tsunami and all that. It's very different today with COVID and everything else. I mean, Malaysia is a great example. We would have never really had Malaysia on the radar, right? And as far as, a COVID impact shutting down, critical plants that impact the whole world. So it's definitely raised that level of need for the visibility to know where the risk points are and what are the risks. Because it could be COVID, it could be ocean container congestion, it could be air freight congestion, it could be a lot of different things, and at least understanding where the risk points are and what are the risks, at least maybe we have an opportunity to do something proactively, maybe that we wouldn't have seen before. So obviously, it's really forcing the discussion, forcing the advancement of having that ability to at least predict something better than we did before. Yeah.
But interesting, as you mentioned, if we remap the supply chain after the tsunami and the earthquakes and other things, that actually the critical points weren't necessarily apparent for now. So and that I think will continue to accelerate and likely shift and change constantly. David, I know that Semi has, and I think you mentioned, but Semi has some groups with the automotive industry, has really made efforts to connect the automotive industry and semiconductor supply chain more closely together. I could imagine that's a group suddenly in high demand, then increasingly high demand. Are you starting to see some results from that? Are there examples where you might be able to see, okay, there's some changes that will hopefully come as a result of this closer partnership between these parts of the supply chain?
Well, I think as was pointed out earlier, we're seeing some shift in the communication or the closeness of the supply chain. It's not just the OEMs, the tier ones, the components, the so forth. They're really talking more aggressively and more frequently across the supply chain. So I think that communication is increasing the visibility. But a lot of the work we're looking at in our areas are what's required for the future, and how do we make sure that we can mitigate any of these types of events as we get there, for electrification and power management and all the elements that come along with that, as we go to autonomous, the processing and onboard devices and sensors and communication with smart city and the roads and that sort of thing. And how does that come about, and what are the devices, what are the technologies required to support that, and make sure that we understand those supply chains moving forward. Electrification probably being one of the most imminent ones, and understanding where is the silicon carbide supply and where is the power management products built, and how is that industry supported.
Absolutely. As well, as David pointed out in the slides up front, virtually every region is investing in capacity to produce more semiconductors. We know here in the US that the Biden administration has put money. EU has set mandates too. That's a theme throughout. Maybe Chris, starting with you, and then I'll ask Raman. I mean, how important do you think it will be for Nissan that supply diversifies into, for example, North America? Again, we heard from David the billions and billions of capital investment and time, so I don't think it can be a quick solution, that's obvious, but is it a key part of the long-term planning?
Yeah, absolutely. It's at the end of the day, it's a demand question, and then it's a supply question. So the more we can get more options, more diversity in supply, as you mentioned, everybody needs that, whether it's here within the region or other regions in the whole. That really, because even if you build it here in the region, as David explained in the beginning, these components go basically all around the world to get to the end kind of product that we use. So capacity overall is going to have to come from somewhere. So as these companies, start developing and investing and getting us to the next level of supply, really it's that interim kind of period that we're all going to be struggling with, but it's got to come from somewhere. So it sounds like it is going to come from, all the regions, to be honest. So, yeah.
Although, and as you mentioned, and as David pointed out, if the tooling for the fab is coming from somewhere else, as ever, anyone who looks at the supply chain needs to know those details. Raman, again, same point to you, but again, obviously for Johnson Electric or other industries, I mean, it's not necessarily all about it being in North America. I imagine it's the global footprint as well. But how do you see the localization piece?
Oh, definitely. I think, as our CEO says, the world will continue to be.
Yeah, now we can hear you.
Okay. So our CEO says that the world will continue to be non-linear. There will always be another crisis. How do we prepare ourselves so we can absorb these shocks much better? To your point, definitely more reliance in region. Where you kind of make and sell as much as you can within the region. Develop those suppliers, dual, triple sourcing. And it's all about information technology, definitely, So we are very committed that, develop some of the local capabilities. The second trend that we are seeing now, the digital communications, the collaborations are becoming much more focused use cases. You made a very good point about decontent, that can you work around the shortage? Can you redesign your product? But in automotive, it is very difficult. If we look at the processes, anytime you touch an existing product that's SOP, there's a whole cycle of PPAP and a lot of things go on. So we are all thinking together. Can we simplify? Can we share this information in much more digital way? Right from the requirements that should not come into a PDF or a visual. It should come as a model, and take that all the way, design the products that are DFM, and you can do a lot of simulations together with your OE, with your supplier, so you can cut down these design cycles. So I think I see a silver lining here in terms of AI becoming front and center. And I tell people that if you don't have a scalable AI plan by the middle of this decade, then you better look for a good retirement plan. So these things are becoming kind of where the boards, the CEOs are pulling the investment in information technology. And I think that's pretty much a very, very good trend, and we need to really make the most out of it.
Absolutely, and I'm going to come back on some of that system points to you. I'm just going to stand for a moment in case, because with the lights I can't see. So if there's anyone who wants to ask a question in the audience, now I can just about see you, do raise your hand and let us know, and we'll make sure you can get to a mic and put a question. So this is still an open panel. So at any point, and if I sit down again, you might have to shout, but that's okay. I don't mind being interrupted. Next question actually is to David, though. I did want to ask you if the bullwhip effect that clearly partly created this issue with the shutdowns and other industries spiking and automotive under-ordering, do we have the risk of the opposite bullwhip now, this extreme ordering, shall we say, which may create issues on the other side? And is that something within the semiconductor supply chain that is a worry or something to kind of work through, maybe not even just across automotive, across the industries it's serving?
Well, I think it's more across industries, and it is a bit of a concern. As I mentioned, in 2020 was a really interesting scenario because automotive production did drop pretty precipitously in March and April. Other industries were accelerating because of working from home and gaming and everything that went along with that. The supply shifted, and so once those production lines were shifted over to the other products and building those, it's several months before they can be shifted back to building the supply needed when the automotive turned back on. As I mentioned, we have seen some double booking in the supply chain, which could lead to some inventory buildup that has to be bled out if things come back online. And, there's always the risk with the amount of capacity being built, particularly with the geopolitical support, let's say, in multiple regions. There is, some risk that there's an overcapacity that leads to kind of a glut in out years. However, as we look forward and monitor the various markets, not just automotive and the growth we talked about, semiconductor content in automotive, but we're seeing that in industrial systems. We're seeing that obviously in computing. We're seeing that in data centers and in the cloud, need for memory and processing and then sensors everywhere, right? So it's really, at a time when AI has become more prolific in nearly every device that we have. We're seeing a growth of all markets in semiconductors. So, while there is some concern of, the bullwhip effect having the opposite impact going forward, there's still a pretty tremendous growth in the desire and the appetite for consuming the chips in the future. So we're trying to monitor all that to see how it all plays out. But it's a difficult view forward as well.
Absolutely. Chris, one of the things, obviously, throughout the crisis, it raises all these questions from an automotive point of view, from a lean perspective, just in time, not that we were necessarily just in time with chips, but these questions of inventory management versus capital, et cetera. As you look to the ordering processes at Nissan for semiconductors, again, is it the kind of AI solutions, looking at the data to try to make sure that Nissan and others don't overstock, but maybe better stock than that has happened up until now?
Yeah, there's definitely a deeper look, and it was already ongoing, but into just your basic inventory optimization tools, right? And really getting in and understanding from an inventory standpoint, how do you need to manage and control all those parts and lead times and risks, and then with that, what are the tools that help you do that? So, there's a lot of tools out there. We're looking at several. We have some already in place. Really, tools that give us a flexibility as far as when new risks come up, that we've got a quick way to adjust and maintain the right kind of inventory floats and all that really kind of protect us against the risks. So I think we're going to see more and more of that. Really needing that flexibility, but also a tool that almost does it automatically or helps you flag really what you need to be looking at. So definitely.
Absolutely. I mean, it was at various points in this crisis spoken with other Japanese manufacturers around, these models, and one of the things that was pointed out, it's not actually to abandon a Kanban approach, for example. Actually, you could argue that one of the reasons that some manufacturers, including Nissan and other Japanese, did better early on is because their ordering was relatively stable when it went down in the past, and they had the supply. It then, Malaysia happened, and that couldn't change it. But Roman, I wanted to go back to the point that you raised earlier on, let's say, the digital transformation of enterprises, of the supply chain in this case, and leveraging that data. And when we've spoken previously in your roles at Visteon, for example, we talked about cloud integration across multiple parts of systems to join things together and try to scale that data better. Is that something now you're embarking on at Johnson Electric, and does something like this issue accelerate that roadmap?
Most definitely, Chris, absolutely. So what I'm seeing now is actually acceleration of, an example would be the smart factory. I think David mentioned very nicely that we are putting a lot of sensors. And to hit that point, one of the most important use cases of smart manufacturing is becoming what I call the first time yield. How can you move your material without scrapping? And if you have to scrap something, to Chris's point, can I find that early on so that the cost of rework or the cost of wasting that chip that's going on my end assembly, I can minimize that. So we are heavily investing in that. And obviously, with the legacy environments, how do you make sure that your operational technology and information technology networks are segregated? You're looking at the cybersecurity. And the most important thing that I'm realizing now is the network latencies. How do you take the decisions closer to the edge, where you have a camera that's scanning the image in real time and telling that this is the bad part, without making a trip all the way to the cloud? So the edge, the cloud, the AI, they all have to work in the context of the business. These are no longer academic exercises. We are solving real life problems. I roll up my sleeves every day. We talk about how do we improve some of the key measures. And the most important thing is, how do I give the actionable intelligence to the role that's responsible for that particular activity? So a lot of evaluations of different technologies, software happening now. But the most important part is for the CEOs, they cannot wait. So as IT, you need to be ready with this plumbing, with the solutions, and ready to solve a business problem. So very, very exciting time from that perspective.
Chris, I know at Nissan, because we had some colleagues at a recent virtual event we did talking about this, some of the data transformation in the Nissan supply chain, I think also a cloud coming in. Is this data layer, and even moving towards AI capability, do you see that also playing a role in this in making this semiconductor supply chain more robust?
Yeah, for sure. I mean, it's that was already in the works, what you're describing as far as cloud-based technologies, data storage, but it's now really accelerated what is I would say the current need and kind of the Midstate need of what is that data that we need to go ahead and figure out how do we best utilize now, giving the semiconductor issues and some of the other. So all of that was in process, but maybe it's tweaked a little bit as far as our priorities on how we're going to go about using it. So we've had a lot of discussions lately around that.
Yeah, absolutely. We have a question in from the audience, and I think, David, this is probably a good one for you to take. So the question is, the chips being used today are often based on technology from circa 2008. This is for automotive. And capacity on more modern chips is allegedly higher tech chips. This is a quote apparently from Fortune magazine. With re-engineering and safety testing timelines being long, is that modernization part of a long-term strategy? Chip makers say, time to get out of the Stone Age. So I guess to summarize the question, I think it's sort of, is the automotive industry at risk of diverging from the growth of the chip industry? The chip industry goes more high-tech and automotive doesn't keep up with that capacity, if that makes sense. Is that how you see it, or do you have a different perspective?
No, it's actually a very good question. And I think if we look back a few years ago, it seemed to be some divergence that, a lot of the parts for automotive were built on legacy fabs that didn't have the ability to expand or upgrade. But in recent times, in fact, I saw a study that we did just recently this year. More than 50% of the controllers going into automotive are at around 45 nanometer or lower. And that's the gate length of the device. So we measure our technologies in 45 in nanometers. Current manufacturing process for high-end Intel processors is on the order of 7 nanometers, 10 nanometers. And so, that's probably not in use in a lot of automotive systems, but, the foundry capacity that's being brought online is in those smaller dimension areas. So there's already been a shift in the automotive design that's going towards the smaller geometries. And I think that's why we're seeing some of the complexities of more of a shift to the foundries, provide, like TSMC, for example, the largest foundry in the world, providing automotive chips, even though they may be coming from your traditional supplier, like an ST or Renesas or otherwise, they're being built in the foundries, because there's very few. In fact, there's only a couple of automotive chip manufacturers that have that geometry capability. And so we are seeing more of a shift to the foundry from an investment standpoint in delivering those chips. So yes, I think there is a bit of a divergence, but I think it's coming back in line, and especially for control systems and the critical systems for autonomous vehicles and so forth. Even the infotainment systems, frankly, are going more towards the leading edge, let's say, closer to the leading edge. Now, they may always be a generation or two behind, but that's okay, because that's where the foundry capacity is. And so as that capacity comes online, it certainly will help resolve the current situation.
Thank you. I think we've, as a surprise for those coming to the gala tonight, we've hidden 7 nanometer chips, but good luck if you can find them. We're coming towards the end, and I thought sort of a last question from my side to the panel. When we're through the worst of this crisis, and whether that is late 2022 or into 23, what's the biggest difference that you hope to see in the automotive semiconductor supply chain to ensure that this doesn't happen again, and then that we keep up with those changes? And Chris, I'm going to start with you on that.
I'll go back really to the need and hopefully the solution for visibility and predictability. So, as has been mentioned, design has a lot to do with that, and I think it's really closing a loophole that we had before from a design standpoint versus really what the capabilities and the capacities are that are out there versus the way, our design or anybody's design would have kind of looked at it in the past. They just assume that whatever they need is there. And I think now it really raises the question and the thought, as they design, they need to understand what I'm designing is going to be available and visible, that they're going to be able to see that is truly an option, or they need to do something different. So I think that's going to be something that really is already shifting just by necessity. So.
And I suppose as part of that, then, that the supply chain and that design, in the design phase, that it can interact. Not that the team can say, well, this is exactly what you need for a chip.
Yeah, definitely further upstream collaboration, not just with supply chain specific, but with really the broader supply base. I think is really what's going to evolve quickly out of this.
And Raman, from your point of view, what do you most hope to see differently in this supply chain?
I think from my point of view, the platform thinking will become kind of a center place now. Traditionally, the OEMs, the tier ones have been very good about the hardware platform, right? The engine, the chassis we share. But the name of the game is going to be around the software. How can you build these software assets that work all the way from the lower level of the SoCs, the chips, to the APIs, and are able to generate the newer features that end up on the modern electric vehicles in a lot faster way, much more tested, and you just assemble them together. I think that's going to be the big aha moment for the automotives, that they need to invest heavily into their becoming software centered. And that's really, I think, is going to take out some of the cycle times of new product development, a lot of cost, and to Chris's point, visibility and predictability. So I'm very, very excited that that trend is going to be very, very organic. It's going to be driven by a business need, no more coming in from an architecture or philosophical view, but it becomes, the platform thinking becomes a business imperative now.
Thank you, Raman. And David, to close from your side, so again, given your perspective across the real semi-supply chain, what's the biggest difference you're hoping to see?
Well, I think what we're hoping to see, and I think we're already beginning to see, it's a shift from a very linear flow of information across the elements of the value chain to a much more collaborative and communicative collaboration on development and needs for systems and subsystems, such that the OEMs are much closer to the complexities of the supply chain, particularly on the chip side. I think there's a much better awareness of the complexities of design and the manufacturing process, frankly. But it's more of a collaborative view of what's needed for the future, and that increases the visibility and predictability that Chris mentioned from that communication across the supply chain.
Gentlemen, I want to thank you all for talking to us and sharing these insights with our audience. This is obviously not an easy topic. We're struggling with it every day, but to take the time to share the insights and look ahead as well with this supply chain audience is so valuable. So a big thank you to Chris Stiles, Raman Mehta, and David Anderson.
Pleasure.
Thank you very much.